Hi guys, I hope you're good, I hope you're well and excited for our lesson today. We are still working with exponents and today we're specifically looking at exponential expressions under the presence of the addition and subtraction sign. So our lesson today will be mostly focused on finding ways to factorize, okay? So now grab your pen and paper and let's do this. So the first part of our lesson today looks at the introduction and it says when working with exponents, so we have to specifically work with exponents, it is also important to find ways to factorize. So as we can look back at our previous lessons when we dealt with normal expressions without exponents, we also worked with them under the trinomials, we were factorizing there. So we need to also bring back factorization under the presence of exponents. So here are the rules we use when factorizing with the presence of exponents. So rule number one, simplify to a form that can be factored. So you need to ensure that you write your expression to a form that can be easily factored, okay? And then secondly, take out a common factor. So this is always important. We need to always look out for common factors. And as we can also go back to our previous lessons, whenever we deal with factorization, that is the first thing that we look for, common factors. So the same will apply here on exponents. We need to take out the common factor. And thirdly, cancel the common factor and simplify. So if we have a common factor as a numerator and a denominator, we need to cancel out those two, or we need to divide them until they give us a 1 so that you can easily have what you are left with at the end. Okay, so first example, let's look at what we have. It says simplify 3 to the power of m minus 3 to the power of m plus 1 divided by 4 times 3 to the power of m minus 3 to the power of m. So guys, let's follow our rules and see if we'll be able to easily factorize and simplify this whole expression. So the first thing that you need to look for is simplify to a form that can be factored. So the first part of my expression simply says 3m. I can't separate that any further, or I can't simplify it any further, so I bring it back as it is. But the second part, going back to our laws of exponents that say if you have a times a will give you a to the power of 2. So we can easily now, if you're given a to the power of 2, it means you can write it again in the form of a times a. So that is what we'll be doing here, because we'll be breaking down that part of our expression, because we need to go back to the rules of exponents that when you have the same base, you can simply add the exponents. That is why on this one, a times a was a to the power of 2. So we'll write this as a 3 to the power of m multiplied by 3 to the power of 1. So I broke down those values, m plus 1 into m 3 to the power of m times 3 to the power of 1, and I divide 4 times 3m minus 3m. So the reason why I wrote that again as it is because I can't break it down any further. Okay, so if you can't break it down any further, you just leave it like that, drop the values. So now we look for common factors. So let's check if we have any common factors. As you can see from the top part, we have 3 to the power of m and also 3 to the power of m on the other side. So you know that you'll have 3 to the power of m as your common factor. When 3 to the power of m goes out, you're left with 1, minus when 3 to the power of m is gone, you're left with 3 to the power of 1 there. And you divide this, you look for a common factor also underneath. You have 3 to the power of m both sides, so 3 to the power of m is a common factor, and you are left with 4 minus 1, because when you remove the only 3 to the power of m there, you are left with 1. So you basically divided it by that. And the next part is cancelling out common factors. So if you have 3m up there, 3m underneath, you can easily cancel them out, and you are left with 1 minus 3, which is going to give you negative 2, and you are left with 4 minus 1, which will give you a 3. So your answer is negative 2 over 3, and you get all your marks there. So guys, this is how you simply work with simplifying your exponents. So now let's go to another example and see how we'll manage to do it. So I have a second example for you there. It says simplify 2 to the power of n plus 2 to the power of n plus 3 divided by 4 times 2 to the power of n plus 2 to the power of n. So we do the same thing again. As you can see, we have 2 to the power of n and 2 to the power of n plus 3. So we need to first simplify this second part. So if I want to simplify the second part, so this becomes 2 to the power of n, I bring it back as it is because I'm not using it, plus 2 to the power of n times 2 to the power of 3. We are going back to the laws of exponents, so we're using it as a converse, so we are reversing it. And then now you have 4 times 2 to the power of n plus 2 to the power of n. Now the next step is looking out for common factors. 2 to the power of n is there and also on the other side. So 2 to the power of n is a common factor. You are left with 1 plus 2 to the power of 3. And you close your brackets, you divide by what is another common factor. It's 2 to the power of n again. So 2 to the power of n is a common factor. If you remove 2 to the power of n from that, you are left with 4. Plus, if you remove 2 to the power of n from this part, you are left with 1. And then you check for common factors. 2 to the power of n is a common factor and 2 to the power of n there, so you cancel them out. And then you are left with 1 plus, what is 2 to the power of 3? 2 to the power of 3 is 2 times 2 times 2, which will give you 8. So you have 8 divided by what is 4, and you divide by 4 plus 1, and an answer for this is going to be 9 over 5, because 1 plus 8 is 9 and 4 plus 1 is 5. So guys, what we did here, we just followed the rules. We keep on following the rules, and trust me, we won't even struggle with anything. So I have one more for you. Try to do it. Grab your pen and paper. Try to do this one and then pause the video. Afterwards, come back to check if you got the correct answer. So, since you are done doing your problem there, now let's do corrections and see what we have. So you have 3 to the power of b minus 3 to the power of b plus 1 divided by 6 times 3 to the power of b minus 3 to the power of b. So this becomes 3 to the power of b minus 3 to the power of b times 3 to the power of 1. What we did is we broke down this value using the laws of exponents, saying that if the bases are the same, you add the exponent. So we just went back now. So we divide this by 6 times 3 to the power of b minus 3 to the power of b. And step 2, you check out common factors. So let's look for common factors. I have 3b on one side and I definitely have a 3b on the other side. So it means I take out 3b as a common factor and then open a bracket. What is left is going to be a 1 minus, so this time we have a minus, so it's going to be 1 minus 3 to the power of 1, which is 3, and you divide this by, check for common factor again, 3b and 3b, you have a common factor there. So you need to take out 3b, 3 to the power of b as a common factor, and you are left with 6 minus 1. So if you're left with 6 minus 1 there, you look for common factors and you divide them if they appear as a numerator and a denominator. And indeed, 3 to the power of b as a numerator is there and 3 to the power of b as a denominator is there. So you simply cancel out those two values, and you are left with 1 minus 3, which is negative 2, divided by 6 minus 1, which is a 5. So your answer is negative 2 over 5. So you get your full points there. And guys, it is not too difficult. Keep on practicing, and I will definitely see you on the next lesson.